Good evening, students. Myself Harshat. Today I going to discuss you a topic, very important topic, which carries very high weightage in IB physics, that is electricity. Now, in order to know that, we should know some preliminaries to understand that electricity. What are the preliminaries we should know? First, I will going to tell you, and then I will take you to the topic today. The firstly, when come to electricity, we must know it should be about charges understanding we must have. If you know charges, types of charges, those are the preliminary things we require. I just going to take you with the screen of on that particular website, and I will discuss that, and then I will take you to current electricity of our IB syllabus. Preliminaries of IB syllabus to go through that about electric charges. So if we know the current is nothing but flow of charges. I is equal to Q by T. So what do you mean by charge? Charge is nothing but integral property of mass. That we going to call it as charge. Charge can exist if and only if there is a mass. But mass can exist without charge. This is the thing we should know in the electric charge. So the electric charge is of two types: positive charge, negative charge. That are the two types of charge. I just share the new screen. Yeah. In this positive charge and negative charge, what we have, the two types of charges. In an atom, the proton contain positive charge, electron contain negative charge. When neutron contain electrically neutral. So proton and neutron in an atom will be present at the center of the atom. That we going to call it as nucleus. Okay. So around it in an elliptical orbit, electrons are revolving. These electrons are there, no? Based on the chemical properties and periodic table, number of electrons will be dependent. Number of electrons and number of protons in an atom is equal. So atom is going to call neutral because proton has positive charge, electron has negative charge. If you remove electron from an atom, then atom become positively charged. If you add electron to the atom become negatively charged. Okay. Then very most important thing that you need to remember is electrons in the outermost shell only can participate in the motion of electric current. That means the electrons in the outermost shell are called valence electrons. They can move from one atom to another atom. Remaining electrons will not constitute in motion of electrons. That is the first thing you need to keep in mind. That I is there, no? That one very importantly, current is represented by I is equal to Q by T. What is Q? Q is charge present in an atom. That very important in the property of charges. Q is equal to Ne, means charge is quantized. Quantized means it is always available in complete number, not available in fractions. 1, 2, 3, 4, 5, 6, like that. It is available in complete number. That we going to call charges are quantized. That is the one concept. One another most important preliminary to go to current electricity is we should know like charges repel, unlike charges attract. Why? That will be the property of field lines. When we have how to write field lines for that, when you have a positive charge, electric field lines moving radially outward. Okay, electric field lines moving radially outward. For negative charge, if you're going to have electric field lines radially inward. And one more important property in electric field lines you need to remember is when you keep both positive charge, both negative charge, positive charge and negative charge, opposite charge, they will attract. Electric lines of force starts from positive charge, ends at negative charge. Okay, and main important concept you need to remember, electric field lines are very strong at the region of poles, means at the end where more number of electric lines are force their electric field is more. That is the another important concept of the preliminaries. So if you have positive positive, that will repel. If you have like this, if you're going to put positive positive charge together, you need to write electric field lines like this outside. They will not going to have. No electric lines of force intersect each other. That is the important concept. Okay, because each point represents the direction. So it should be going away. That one will be the thing you need to go. Then next part in the electricity must known thing you should have the preliminary is the current is nothing but flow of charges. When the flow of charges is present, there must be a magnetic field also. When charges under rest, you have only electric field. When charges under motion, you have electric field as well as magnetic field. Both are perpendicular to each other. That is the preliminary you should know. Okay. Now, let me take you to another concept. Static discharge. The best example for static discharge is lightning. Okay. That one we're going to learn in electric fields. Now we're going to concentrate on current electricity. Continuous flow of electricity is called a current that going to have electric and magnetic fields. When we have that, we should know on the electricity is a basic force. There are four basic forces in nature: gravitational force, nuclear force, electric force, magnetic force. Very strongest is nuclear force, very weakest is gravitational force. Now we go into the current electricity. Actual current electricity start from here. In order to flow electrons in the circuit, there must be a two conditions should satisfy. The first condition, there must be a continuous path. There is no breakage in the circuit. Second, there must be a potential difference. That is the second most important thing you need to remember. So in order to create potential difference, we use battery as cell. If you have a single line, bigger line and smaller line, then if it is only one single line, smaller line, that is the symbol of cell. If it is a combination of cell, then it's a battery. And you should know that potential difference and continuous path are the first preliminary things in order to flow the current. It was how much current is going to be in the circuit is explained in Ohm's law. What Ohm's law says that? Ohm's law says that amount of current flowing in a conductor is directly proportional to potential difference applied across the terminals, provided temperature and other parameters constant. Ohm's law is applicable only when temperature, pressure, humidity will be constant. If it is not constant, Ohm's law is not applicable. The devices which obey Ohm's law are ohmic devices. Devices which doesn't obey Ohm's law are non-ohmic devices. Ohm's law is not a universal law because it can't be applied in all the conditions. It is applicable only under constant temperature and pressure. Those are the preliminaries. Ohm's law is not applicable for semiconductors. Ohm's law is not applicable for ionic solutions. These are the very important limitations. We should know in the exam, they're going to ask you, give a Ohm's law limitations like that. They're going to ask you for 2 mark. At the time, we should know. It should be not a universal law. Why? Because it has limitation temperature. It will not be for semiconductor and also. For that, you should know what you mean by semiconductor. Materials are classified into three types based on their conductivity. The firstly, conductors, insulators, semiconductors. Conductors, they allow electrons to pass through them easily. Those are the first type of materials are called conductors. If these, the one which not allow electrons under any condition, those are insulators. Example, plastic, rubber, those things. For conductors, all metals. Okay. When come to semiconductor, it is going to be widely used in our electronic devices. Okay. At that time, we know that the materials which going to behave like a conductor if condition is satisfied. If that condition is not satisfied, it behaves like a insulator. What that condition? That is our particular cutoff threshold voltage. For silicon, it will be 0.7. For germanium, it is 0.3 volt. Below that, if the voltage is there, it will not conduct. Based on that concept, we're going to have semiconductor devices. What are semiconductor devices? We're going to have diode, transistor, amplifier. That those are the things we're going to use more in the electronic devices. Okay. So that are the preliminaries. That one we're going to have. Now let me take you to very important concept. Ohm's law, as I told, V is equal to IR. That means R is nothing but resistance. That is the opposition offered for the flow of current. That can be given by R is equal to rho L by A, where rho is resistivity, L is length of the conductor, A is area of the conductor. If the given material is very large, means resistance is more. If given material area is very large, means resistance is less. Okay. Rho represent resistivity. Now, this is the base problems I will take you in the next part on this. Now I will take you some problems, simple problems to make you understand. Today, just a demo, I given you on Ohm's law. In this topic of IB, you should know basic start with atom structure, electrons, how they behave. Then you can understand Ohm's law. Then we're going to have electric power. After we have resistivity, series and parallel circuit. Later KVL, KCL. These are the complete syllabus. For all that to need, the basic part is Ohm's law. And also series circuit, parallel circuit, how they work. I will just cover that syllabus in this demo. Just have a note. If you have series circuit, what is the meaning of series circuit? One end is connected with one end. That we going to call series circuit. If you want to replace this, all three resistors are in series into equivalent resistance. We're going to use a formula R total is equal to R1 plus R2 plus R3. How, why it will be using in series circuit, very important thing you need to remember, current flowing through all the devices is same. That's the most important thing we need to know. In parallel circuit, both ends of the devices are connected. Not only for resistor, you can go for capacitor, inductor, all will come. In series means current flowing through all the devices is same. In parallel combination, voltage across all the devices is common. That is the thing you need to know. The current to measure, we use the device ammeter. Voltage to measure, we use the device voltmeter. In parallel circuit, we're going to use the formula 1 by R is equal to 1 by R1 plus 1 by R2, like that. And one more important tricky formula I'm going to give you. In the parallel circuit, what you have here, you can use the formula Rp is equal to R1 into R2 divided by R1 plus R2 if only two resistors are present. That is the one thing. Another thing you need to know, most importantly, when you have n number of resistors have same value. For example, R is the value, n number of resistors. If they are connected in series, the equivalent resistance is more than the highest resistance in the circuit. Okay, so that will be n into R. If those n resistors are connected in parallel, then equivalent resistance is less than the least resistance in the combination. I will explain you that one now. For example, you are going with 5, 6, 7. These three resistors, if you connected in series, what we going to get equivalent resistance is there, no? That should be greater than 7. That means more than the maximum value in the circuit. What we add 5 plus 6 plus 7, you're going to get 11, 18. That is the way you should know. When you, the same resistors, if you connected in parallel, their equivalent resistance must be least than the least in the circuit. Those things you must be very confident. Okay. If a same number of resistance means 50 number of uh, 10 ohm resistors are connected in series, then equivalent resistance is need not to add 50 plus 50 50 for 50 times. We just use n is 10, R is 50, you're going to get 500 ohm directly. For parallel, if they do 50 by n, that is 50, sorry, this is 10, R is 10, then this will be 50, you're going to get 1 by 5. Like that, you can easily find the series and parallel circuit. Now let me take you to one of the textbook questions in your syllabus, what you have IB. This preliminaries, if you have, you can able to understand the concepts what we have in the IB. Without that, you are feeling difficult. Now I will share back to the screen for current electricity part in our IB textbook. Yeah. Now let me take you to the current electricity part. Why current electricity is important? Maximum weightage is that you're going to have projects. So I suggest when you're going to start your work, start with first current electricity, then you go for another topic like wave, kinematics. Projects will be easy when you choose the current electricity chapter. So first we need to learn the current electricity first. One second, I just opening the textbook. As we know, resistivity will be not going to be affected any length or area. That will be very easy. That one for conductors, it will be very less. For insulators, it is medium. When we come to particularly for insulators, very maximum value. So if it is maximum, you can understand it will be not going faster. Those are the things you should know. Let me open. Yeah, I just share the screen back. Now you can easily see the first concept in your IB. They are started with series, ammeters, voltmeters only. As I told, the symbols, those are the beginning part of our discussion. But actually, when we come to this current, electricity, and magnetism in our chapter, I just increase the size. First, you should know the circuit diagram. Circuit diagram means what I give you. Always current to flow, two conditions should satisfy. First condition is there must be a continuous path. Second condition is potential difference. Always current is moving from positive terminal to negative terminal, that we going to call conventional current. Actually, current electrons will move from negative terminal to positive terminal. If you go on directly to the circuit diagrams, you are confusing. So I start with the resistance, Ohm's law, resistivity, those things, power dissipation. Okay, Kirchhoff laws. Resistance is the flow of opposition for the flow of charges. Ohm's law, I already explained. Now, let me give you the concept of Kirchhoff law. There will be two laws in the Kirchhoff. The first one is conservation of charge. Second one is conservation of energy. Kirchhoff first law tells you no current will going to be stay at the node. What the statement tells, algebraic sum of currents at a particular node is zero. What that mean? Algebraic sum of currents. For example, in order to know that, you should know what is the meaning of node. What is the meaning of node means the number of wires connected at particular point, that we going to call node. If you have a current direction like this, when you have like this particularly, the current which are coming towards this node, you can mark this as I1, I2, I3, I4, I5, I6. The current coming to this node, call this node as A, are positive. The current going out of this node is negative. Those are the thing they're going to tell you in the law. Algebraic sum of currents is zero to a particular node. It means incoming currents is equal to outgoing currents. Here I1 is coming towards the node, so positive. I2 is coming towards the node, positive. I3 is coming towards the node, positive. I4, positive. But I5 is going away, so negative. And even I6 I put it as positive. Okay, that equal to zero. That is the Kirchhoff first law. That is also called junction rule. Kirchhoff second law is telling about mesh that will be required, energy conservation. I will discuss that problems. Just I will show you in the introduction. Now I will take you to this. Ohm's law, as I told, the devices obey Ohm's law. They have a linear graph. Those are ohmic devices. R is equal to V is equal to Ri. In this gradient, you're going to get 1 by R. These are the one ohmic device you need to know. Okay. Then more importantly, we should know Ohm's law is not applicable for semiconductors, non-ohmic devices. This is the filament lamp example. Okay. Now we're going to show you only one part you need to know. This is the ohmic conductor. There will be a linear relationship. This is filament lamp. It will not obey Ohm's law. Even semiconductor diode, it also not obey Ohm's law. As I told, semiconductors will going to become conductors if they satisfy the condition. See, after 0.7, it will satisfy. Until then, for silicon, it is 0.7. For germanium, it is 0.3. Then you can see the IV characteristics of thermistor. What is thermistor? The temperature controlled resistor. As the temperature increases, resistance decreases. That is thermistor. It also not obey Ohm's law. Neon tube. This also not obey Ohm's law. Okay. This is the small introduction what I can going to give you. I will discuss you the problems and remaining part of our IB syllabus and projects in upcoming videos. Combination of resistors. These are your syllabus you have. This is about color coding of resistors. Color coding of resistor means by seeing the colors, we can identify what is the value of resistance, that is color code. It is very easy to remember. You should know B.B. Roy of Great Britain having very good watch with gold silver needle. That means that is the way you can remember the colors. I discussed that in the regular class. This in demo video. I just give on that. It is parallel, all those things. Okay. This about a small introduction on current electricity. I will see you soon for a regular class. In that, we will going to see you the remaining part. Thank you. Have a nice time. Take care.